This is Kevin. I'm a fourth year mechanical engineering student, and this is my project for design and manufacturing for Dr. Hassan Rashidi's class. For project 2, students are tasked with choosing an item that personally bugs them and suggest and make design improvements or modifications or parts to address the problems they have with the product. Just before beginning, disclaimer, this is solely for academic purposes, and let's begin. So for project 2, I have chosen Yeti's travel mug. What the travel mug does is it's a gray thermos which allows you to maintain the temperature of your hot and cold beverages for longer, and also provides a good seal for carbonated beverages. However, when using this product, I encounter some minor problems, such as it is difficult to open the lid, especially when I'm trying to clean the mug, since my hands would usually get wet and it would cause it to be slippery. I would also have to position my hand in a certain way to utilize the ridges that are designed on the mug. And the other problem I have is the low flow rate when drinking not hot beverages. Like if the beverages are hot, the design is good since the low flow rate would mean that I do not scald my mouth when drinking hot fluids. However, when it's cold, I would prefer more fluid flow. And this is the concepts I would be using to address the low fluid flow rate. So for the top right diagram, you can see that there's only one opening, and for that one opening, air has to flow in and water has to flow out to maintain the same pressure inside and outside of the container. This is when you're trying to drink the liquid, so that means that the water flow would be lower than if you were to have two openings, such as on the bottom one, where one is dedicated for air flowing in and water flowing out. So this design changes I made is to increase an extra hole for air inlet, and also make a stopper with a silicone seal to maintain thermal conditions inside the container when you're not using it. So the stopper and the silicone seal can be pulled out when you're drinking fluid that's not hot and you want more flow rate, but when it's hot, you can just keep it inside, keep it plugged in. And so for the top right image, it shows where the fluid will be flowing in, where the air will be let in, and also that the middle section, which initially seemed clear, is occupied by the slide tab, as shown by the image on the bottom right. So for the second problem of trying to open the lid, the concepts that I will be using to address this problem is increasing coefficient of friction. It is hard to um, it, it it's usually hard to open the lid because the smooth surfaces on the lid makes it easy to slip, especially when your hand is wet. And to address this problem, I'll be adding more ridges along the sides of the lid to increase grip and also increase the coefficient of friction, which means that the force applied would be more effective and there will be less slipping. So here is the design and modifications I made. You can see on this bottom right, there are more ridges across the lid to increase the areas where you can grip on the original design. But you can see on the bottom left, there's only a few ridges on the top, which means you have to position your hand in a specific way to utilize them. But with the new design, you can more easily access the ridges without having to position your hand in that one specific manner. For the new design, I chose not to add ridges along the area where you would be drinking because those would make it harder to drink out of the lid. So to manufacture the materials, the clear lid and the stopper will be made out of propylene 5, which Yeti is already using. These are food grade plastics, and to manufacture them, they will be made via injection molding by heating the plastic and then injecting them into a mold cavity. This is the best method for producing such material because the lid has a lot of features, as seen here, with the ridges and also the openings and the helix to close the lid on the mug. And while this will minimize the number of steps you need to manufacture the lid. And for the silicone seal that goes on top of the stopper, as seen by the red component there, it will be made out of silicone, which is food safe and will be used to provide a better seal to maintain the mug's temperature when storing liquid inside of it. And to manufacture the silicone seal, a silicone and carbon-based material will be melted in a furnace to make silicone, and they will be poured out into a mold similar to injection molding the lid and the stopper. So, what are the pros and cons of the modifications? The pro is you can make the fluid flow rate more steady, and there will be more fluid flow if you pull out the stopper, and the lid will be easier to open. However, adding all those ridges makes it aesthetically less pleasing, and the extra opening would also mean that the beverage might not maintain their temperature as long. This also applies to carbonation, since the extra opening might let carbonation escape more easily, even with the seal. And this is also more parts compared to the original design. Yeti made a pretty great product for disassembly and assembly to clean the mug when you're using it. And this is my works cited. Thank you so much.